And yeah, with that further note, he's going to tell us more about integrating phenomics and phenotypes into agricultural databases. So go ahead, John.
Okay, thank you very much. And sorry
Josh.
for me just rolling right over you, but thanks for that. And I definitely am looking forward to the community workshop. I was just chatting with Marcella ahead of time. My plan was to actually go to the National Science Teaching meetings in Anaheim and present there the week before, and then go to Kansas City, and then go to our state, Washington State Academy of Sciences program on growing with AI, the use of AI in ag. But then my niece announced that she was getting married in Alabama on the 17th. So that took out a couple of those trips. But I will be at the community workshop in virtually. So this topic obviously has been around for a while. The RCN has, supported a working group on phenomics, moving on from the original start with genetics and genomics. As we know, research more and more is integrating them, and again, going back to the early tech when you talk about the KEGG pathways or things like that, where there was, some basic connection between gene sequences and enzymes and proteins and things like that. And of course, our technology has proceeded apace. So, right from the get-go, I never planned for this to be a technology-heavy presentation. All of you on this call do more of this than I do, and you know the technology. It's really much more strategic planning. For example, the grant that we're working on right now is one. And before I start the slide set, I just wanted to mention that I had the opportunity to go to the USDA Ag Outlook Forum in Crystal City there 2 weeks ago. And of course, that's a big strategic level kind of presentation on commodities. And they do talk about the research programs. And in fact, our folks from WSU Wenatchee on Apple Sensing were there presenting their work. And also to this end, there was one major session on using AI and databases in seed selection. And in that, it was some examples of corn genetics of how fast we can now um, identify new traits to include with the use of AI technologies, but because the databases are there, because the genetic and genomic databases are there. And they did also, yeah, Marcel, I'll start sharing here in a minute. But the stuff going on, Doreen's work at here at WSU was mentioned in that study. So this is happening. This is real. So we will start the slides here. And looks like I've got to go back. Okay. So again, this is going to be broad, high level, integrating databases, why we want to do it, and what are some of the ways we need to make it happen. And so toward the end of my summary here, Marcella's going to drop the Google Doc slides into the chat, and I would ask you to contribute these. What are you doing in terms of integrating databases? And again, broad level kinds of things. What are you doing now? And if you're not doing anything, or if you are doing, what do you want to do? What do you think should happen? Okay, in terms of integrating databases, and don't limit it, please, to just genomic, and phenomic. Think broadly. linking all databases. As you know, there's tremendous conversation and there's funding out of USDA on farm databases, ag information writ large, crop management, soil management, those kinds of things. So please be broad. And what is preventing you? What do you need? Okay. So again, not, if really the major block is, we don't have the technology to do X, then put that in there. But more globally, what needs to be done? Why do you want to do it? What do you need? So I want to introduce this with two relevant books. They may not seem like they're relevant to this, but after you read them, they will be. One is called Impact Networks, and I got that from another group that I'm working with. Very, very well done description of all the different types of networks. So we have our research convening network, and we have other kinds of networks. What is their purpose? How do they work best? And I would really, really encourage uh, all of you to take a look at that. And that actually, another report that I brought up about every meeting is the National Academy's report on collaboration among land grant universities. And if you just look up Banner, BANR land grant, you'll find it. And we address these very issues of how do we get people to work together, for example, on database management. And the other one is, I see my font didn't work here, Learning with AI. That's the name of the book, Learning with AI. If you type in teaching with AI, you're going to get about 100 books. But Learning with AI, this was just published last year. It's an NSTA, John Hopkins press book. She is outstanding on using AI for the purposes and mechanisms for which it was designed. Okay. That is, it's the people that are creative. It's not the technology that's creative, it's the people that are creative and using it. So as you're thinking about how you would use combined databases, how could you use AI to further your creativity and efficiency? So I'm going to actually start here. These slides I'm showing you were generated by ChatGPT after a fairly long set of conversations, and I'll share those with you as you want. This was my first prompt on this topic. Write an outline, less than 1,000 words, on applications of phenomic databases, on various different types of production, include the OSTP memo, and include up to 20 key review papers, white papers, grant RFPs. So one of the things when you're using AI is, prompt engineering. And in the early days of them, I would hear from colleagues in different networks, oh, I got this spurious thing and the references weren't correct and stuff like that. Well, of course, these things are updated by the minute. But now, in my experience, if you write your prompts very, very well, you can get some pretty good information. And so from this prompt, I got pretty long list of what's going on. And then I did this. Okay. This was my prompt. All right. Databases, phenomics, genomics, sustainability, funding, looking up NIFA, USDA programs, related databases. But I told it, don't use the Ag Statistics Service, Ag Commodity databases, include our own work from AgBioData, the summaries of these three NRSP projects that you should be familiar with, but animal genetics, animal nutrition, and overall genomics. Make a summary of the Hyatt level needs, and I tell it it's a big ask, but try to limit to the top 15 to 20 major points. Why do we need to integrate genomics and phenomics databases and other databases? How do we integrate genomics and phenomics databases? Again, not a lot of technological. And how do we sustain such databases? Now, think for a minute, because we did this, and Leonore, and you were there from the get-go, and we had these conversations from the beginning. How do we put these things together? What do we want to know? And it's interesting because I asked to limit it to 15 to 20 major points, and it did on this question, but then it added about another 20 more on these two questions. Okay. So you had a little bit of the human touch there. So from that, and these will be available for you. Marcella's put the slides up. These are the links to that Chat GPT. So if you have Chat GPT, you should be able to find those. And it said build a PowerPoint. And this was kind of funny. So don't crowd the slides, 4 to 6 bullets max. Well, it ended up that it still crowded the slides. So I went through them all, and that's what we're going to do now. So again, I mentioned that this was going to be a strategic level talk. So I'm not going to go into a tremendous amount of technical detail. I'm looking at this as how, for example, Marcella, you and David just met with the NSF rep for the grant. You talked about some of the specific things at the grant, but they were still fairly high level. I mean, you didn't get into the, specific software you were going to use every day, those kinds of things. So why do we need databases? Well, biology operates across various scales. Trait discovery requires linked genotypes. So those of you that were involved, both with the NRSP 8 and 10, where, and they talked about this at USDA last week, using these databases, using these genomic databases, we are now selecting crops and cows and chickens and pigs with genomic proofs. And, those of you that were involved with that, that went really quickly. I was amazed how fast it went from the genomic programs to having genomic proofs. And it could go that fast because we had massive data sets on phenotypes. So we could link the genotype to the phenotype fairly quickly. And, just to belabor the obvious, nutrition is phenotype expression, metabolism, all the various pathways, utilization of nutrients. So the National Animal Nutrition Program, the forward-facing piece of that is the NRC book, so nutrient requirements of dairy cattle, nutrient requirements of poultry, which are based on, for example, what's the genetic ability of the animal to make milk, milk protein, milk fat, and then back calculate through all the empirical data to nutrient requirements. And those are phenotypes. And then, work that I did in dairy cattle, linking the mRNA sequences to what's actually going on in the animal. So still phenotypic stuff, but then other people could take that and link it back to the genomics. So the historical databases are there for us to use. And the Chat GPT put out a number of points on climate resilience. I just summarized them here. Clearly, we need integrated data for crops and animals in climate adaptation. So you all are involved with this. Genetics times environment times nutrition modeling is impossible without integration. Translational agriculture. So for example, we were just talking about changing weather patterns in the winter or animals that are being bred for water resiliency and weather resiliency, those types of things. We need those phenotypic layers. Okay, precision agriculture. So I've been working with the National Resource Conservation Service on precision feeding of animals. And you need to have, okay, so one of the things with poultry, if you're not familiar, we are now from hatch to harvest in like 33 and a half days. And you better believe they have that down to the minute. And they have the computer technology where they're, and it's a pretty simple thing. They have a vitamin mineral mix and they have corn and soybeans. And so those things will change mix every day. Every day they'll change the feed mix because that animal is growing so fast. And that's all phenotype. They select the animal for the phenotype they want, and then fit the environment to that. So across the board, okay, and this is where again we're getting bigger than just genomics. So the classic tomato that lasts forever but might not taste as well, the strawberry that lasts forever but might not taste as well. Now we've got the technology to pick the different genetic combinations, but we have to put that together with the soil, the latitude, longitude, weather, all of those kinds of things. Livestock sustainability. So I was just in London at the beginning of the month. The Gates Foundation and the Global Methane Hub they're doing a pretty amazing study. They recognize, okay, that methane from cattle is not a major contributor to total greenhouse gases, as some people would have you believe. It's about 4 to 5%, but it's a larger contributor in terms of agriculture, and it's something that we might actually be able to improve the efficiency of animals based on their methane emissions. Because if you're not familiar, methane generally is inefficiency of feed use. So the Gates Foundation, I'm talking hundreds of millions of dollars to ask two questions. Can we select cattle on low methane production? Okay. Now just stop and think about that for a minute. Even if you're not that familiar with animal metabolism, you're familiar with crop metabolism. What does that corn plant need from the soil and the air to fulfill its genetic potential, right? So when we put together the rumen microbiome, the trillions of bacteria that are in the rumen, all of their genotypes, the genotype of the animal, the weather, the feed, and they are spending the money to look at database integration on that. Okay, all the way to the animal genetics, phenomics, the metabolic models that I used to work on. We're resurrecting that. Just to ask that question, can that be done? Can we do that? And I think that for us involved in the steering committee, for us involved day to day with AgBioData and our friends on board, those are things that I think we can get funded relatively soon in the next few years. Okay, use of AI. Okay, it requires integrated data sets. You just saw, and again, I didn't show you the entire conversation. But again, I wasn't just blindly taking what ChatGPT said was what. I went through it and I'm very impressed at what it can pull out of our stated work, right? So it goes to our website, it goes to the white papers we wrote, it goes to our peer-reviewed data. It is pretty impressive on what it can pull out of that, okay? And then, again, if you're at all awake, on your news feeds, whether you're on straight news feeds or Science Society's news feeds or Facebook news, workforce and education and use of AI is the topic. It was the topic at NSTA. How can these things be used? Policy level work, okay? One of the things at USDA, this is really interesting. If I asked you, I won't, but if I asked you to put in the chat, now just stop and think for a minute of the burning topics that USDA is dealing with when you take away tariffs. Okay. So that was a different conversation. They definitely addressed the tariffs there. But when you take that away and you look at like beef production, dairy production, um, commodity, nutrition. Okay, we had a session on the nutrition and the dietary guidelines in the food plate. The two biggest issues that were developed out of the actual data. So when I mean actual data, the actual data on the beef herd, the dairy herd, of why it was changing the way it was, and what those changes were and what they meant to prices, was beef on dairy. And if you're not familiar with that, there's so much demand for beef that the dairy industry is actually breeding more and more cows to beef bulls and selling them as beef bulls rather than dairy heifers or bulls. And some of the prices, for those of you that are, I mean, you're talking about selling calves for $1,300 a piece. Okay, that's what you used to get for a high genetics cow. All right, so there's a lot of weirdness going on there. That was tracked in large part to the use of GLP-1 inhibitors. And if you're not familiar with that, that's Ozempic, Wegovy, Mounjaro. And in fact, the use of that drug is so widespread now that it's changing the food buying patterns of the United States and therefore the production patterns, specifically in beef. And so about 13 to 14% of the American population is on the GLP-1 inhibitors and in their early phases. And I can speak to this from personal experience because I lost 64 pounds with them over a 6-month period, and I've kept it off for 2 years. It forces you into a high protein diet. It's a low calorie, low carbohydrate diet. You don't eat. And so, in order to keep your muscle mass up, you increase protein. So, it's really changed the way people eat and buy food. And what's that got to do with us? I mean, all of these things tie in. These are the database connections that are being made right now. Public trust and transparency. So, for example, the session on the food plate and nutrition, human nutrition, now I'm talking about, of the Dr. Eve Studi, who's been there for 20 years. She gave a wonderful, wonderful talk, just talking, no slides, no nothing, just talking about the food requirements, diet. She didn't get into the political stuff or the nonsense of individuals involved, but why, big news here. Sugar is bad and meat and milk are not. Okay. When you come down to it, that's what it was about. But when you look at this public trust and transparency, clearly the way it was done, the way the food guidelines were changed, is not the way we want to do things. Okay. So, strategic level, as you know, to come back to funding, and again, it's simple, advocacy 101, funding 101. Those people on the ag and food committees, those people on the ways and means committees have to have the ammunition to say, this needs to be funded above all the other things that people are asking me to fund. And even though we don't necessarily work at that level day to day, we need to be aware of that. Okay. It's not a scientist at a university that changes the mind of a U.S. representative. And I'm not, and even again, putting aside all the crazy things that are going on, this was long before that. These representatives, everybody's asking them to spend money, right? So how do we get higher on the list? Okay. So how does this happen? What we're working on, this is what we're doing, right? These are things that we're doing right now. And people have gotten grants on these fields. We've put out white papers. There's a lot of interest going on in it. So we're doing that. We're involved with that. We have had working groups on these things. So when you think about it, and we've talked about this in the steering committee, we have working groups on biocuration, on ontologies, on these kinds of things. And they're all important, but they all use databases, right? They all have to be able to use various different databases at different levels of integration. So, for example, at San Diego at PAG, we had some nice conversations, and several of you on the group are involved with NRSP 8, NRSP 10. Obviously, we had whole day sessions on those, and the conversation of how can they be more cooperative? How can they be more specific to building some of these bigger research issues? And one of them is just in animals. In animals, integrating genetics and nutrition. Again, as they say, that's kind of a no-brainer. Everybody wants to do it. What we're struggling with are how are the ways that we get funding to do that, okay? And then integrating animals and crops. All right, we do that in the field, right? How are some of the ways that we can speed that up with research and teaching using integrated databases? All right, so linking platforms and incorporating environmental, and then using machine language. I mean, that's just going to be the technology that's being used. And so when you're talking about, and we've had these talks and actions, we'll be talking about them in Kansas City and virtually. How do we get this to the funding level when we talk about sustainability of databases? And there's been very good conversations on that. And again, the Some Knowledge, the AI program, pulled these things out of what we've written, what people in the field have written. We want public-private models. We will have commodity groups that we've talked about. There's going to be databases for several different reasons that are ever only going to be used by a smaller group of people, but they need to be there, okay? They're part of the system. They need to be there. There's going to be bigger databases, dairy cattle genomic proofs, poultry genomic proofs, corn genomic proofs. These are going to be used by larger numbers of people, okay? And we have the structure. We have the structure at the national level. We don't need to reinvent the wheel. How do we build that up? How do we get more funding for that, or more activity for that? And so these are some how-to types of things. And Marcella, if you can go ahead and drop that link to the open PowerPoint into the chat, I'll bring that up here in a minute. Okay, so this is one, and this is one that I personally have struggled a lot with. How is it going to be used? So, for example, an example that's already out there, the NANP NRSP 9 is the Animal Nutrition Program. And this actually was created when the National Academy dropped the Committee on Animal Nutrition. The National Academy is the organization that for 100 plus years put together the National Research Council requirements of animals books, sum up all the data on feeding dairy cattle, put it into empirical equations, put out the feed tables, and this is what we'll use to feed and breed dairy cattle. Okay. Okay, so now it's all computerized. So we have websites that anyone can go to. So if you're a private nutritionist, you can go to that website and find the database. I mean, the database on the chemical composition of all animal feeds. Okay. You can access the NRC for poultry. Those are public information. You can use those equations in your own consulting business. You have to use those equations if you're doing feeding. So dairy science, poultry science, animal science, we all have a requirement for publication. If you're feeding animals, you have to say we're following the requirements of the latest NRC book, unless you have data to say that's been changed since. So that's part of our world already. So how can we keep building on that? Okay. And finally, as is quite often the case, and this is what ChatGPT churned out as the 35th of 35 major points. Embed education and workforce development. I mean, literally, that's the way we write about it. Oh, yeah. By the way, we also have to educate people that are working in the field or people who want to work in the field. And that's why I was so happy when this group, put together that course on databases, on using databases, because that's so important. Okay. All right. So here we're back at the beginning. And now I'm going to ask for your involvement. Integrated genomic phenomic nutrition. What are you doing? Okay. What are you doing? What do you want to do? And what is preventing you? So I'm going to stop sharing. And in the chat is the link. Now, Marcel, I'm going to need your help here. So they can go to this, right?
Yes, should be
And just
edible.
start typing in, and then we'll be able to see it, right?
Yes, correct.
Okay, so if I share my screen again, so if you folks can open this up, this Google Doc, and find it, uh, and then I guess at this moment we got about 20 minutes left. Are there any questions or comments on what I've blasted through to this point? Fairly strategic level stuff. Just kind of raise your hand or start talking.
John, would you like me to share the document so you can?
Yeah, I was going to give people a chance to ask questions. There's Doreen.
John,
Doreen, go.
so I found this was very interesting because I didn't know about the database about the nutritional components. One of my commodity, well, at least two of my, well, many of the commodity groups I'm working directly with, um, they see animal feed as potentially an area for product development, for instance, right? And so when you're saying what do you need and what are you looking at, I'm looking at from the plant side, which is a little different, is how do we get what we need from you guys to understand requirements and or quality traits associated with the food, to make that work. Does that make sense?
It makes perfect sense, and thank you for that. That is exactly what that is there for. And so in that group, we've had talks like this group has. So this is all publicly funded data. Now, yes, feed companies also pay for some research, but they know that if it's going into a peer-reviewed journal and I've done it, that's public data. Okay. If they want to contract me for a private, like FDA type approval, then that's something else. But that's why NRSP 9 was when National Academy stopped the committee, ARS realized it was so important that they actually got money to keep that going. And so that's exactly the kind of thing. if you are working with a crop group who wants to check or say, hey, look, one of the things, this goes way back I mean, literally like Norman Borlaug type crop selection, okay, into the 70s of high lysine corn. We know animals need lysine. Cereal grains are notoriously low in lysine. So can we make grains with more lysine? And the answer was yes, but they had a lot of other problems. But nowadays we've got better data. So yeah, please put that in there. Other questions or comments on that, on any of that? All right, yeah, if you go ahead and share that, Marcella, and then please do open that up, and I'll give you some time without me talking. To put your thoughts in there. We're getting good. We're getting some some things added here. Feel free, we'll share this with the group. And these are some of the things we're talking about for grant opportunities. And thanks for putting the pet food in there. People in ag kind of don't understand how massive effect the pet food industry has on
Oh,
crops.
fur babies, guys. They're the new kids.
That's right. That's exactly right. That's a conversation. So the last NRC update on companion animals, on dogs and cats, is now 21 years old, and it's an example of what got funding. The previous ones, the separate ones for dogs was 1984, for cats was 1985, and by 1995 the pet food industries publicly said, we are not using the NRC books because they're so out of date, is that they're not functional. And that was 1995, and it still took the process started in about 1999, and it was 5 years. So I actually published my textbook the year before the NRC came out, and they were trying to say they were going to use that as a textbook at a cost of $295. And this was never meant as a textbook. It was meant for research. So that was a big, big thing, and we're talking about that in the academy right now. That needs an update. Okay, somebody's going to town here. Well done. Okay, this is okay. Yeah. Yep. Thank you for putting that in there. Other ideas? I won't call anybody out, but please do. Here's soybeans. from the anonymous chipmunk. Thank you for that.
John,
Yep.
are you looking for this to be animal specific, or are you looking this to be generic agriculture?
No, across all of ag. All of ag. So, like you said, if you're working with product development, you think about all the things you need to do when you're doing a needs analysis, a market analysis. What are you basing your work on? From my aspect, working with the other groups in agriculture, so our Washington State Academy of Sciences, as I mentioned, was asked by the state study and get people up out here from across the board in agriculture. So farmers, workers, specialists, not just scientists, but scientists, teachers, community leaders, business leaders. What do you need? What are you thinking about in terms of use of technology, use of AI technology? So, literally, like the food plate changes. It's already changing what we do. I mentioned the change with GLPs, and the assistant director from USDA of the USDA economy of the economics group talked about the GLPs of how it was changing marketing patterns. So for those of you that go back a ways, and you remember the cholesterol-free bread wrappers that came out in the 70s when, cholesterol was the world's worst enemy. So you'd go to the store and you'd buy cholesterol-free bread, which never had cholesterol in it in the first place. And now this assistant director at USDA, she shows up a picture at Chipotle of their chicken bowl. And the chicken bowl now says high protein. And she said, of course it is. It's a bowl of chicken. But the point of that is there's a lot of pent up need for databases. And our job, how do we get in there? How do we get that funded? Okay, look, we're having some good information here. Okay, that was my seed thing. Support from ag and science communities. How do we talk to each other to get this done? Germplasm for animal feed, absolutely. And the same thing, germplasm for human food, pet food, all of that. And then this is from Damien, and thank you for, massive, how do we tie all of these things together for research, and again, as well as teaching, I would think. Aquaculture, so this is, again, I think from you, Doreen. And, yep. All right. I'm not sure if we're still getting input into that or not, but I'll ask, so any questions or comments? Any comments on how where you think the AgBioData or friends should be going in this direction? I've been told that my wait time is too short, so I'll wait a little bit. See who's still going on here. Biosecurity. Yep. One of the things that hasn't come up in this group right now, and actually I kind of thank you for it because it's one that comes up all the time and it's kind of a conversation starter, and that's data privacy or data security. And if you look at that from one aspect, we've known how to keep data private and secure for a long time. Now, again, you can look at the craziness going on. It's like locking your door on your house. If somebody wants to get into your house, they'll get into your house. It's just a matter of how hard it's going to be. Rex, go ahead.
I was interested in your comment about on-farm data. Is have you heard any talk about how that could be accomplished?
Oh yeah, I mean right now. I mean, so our and so coming back to our state Academy of Sciences was asked. So for example, taking I'm sorry, real world in time data on soil temperature, soil salinity, potassium, nitrogen, phosphorus, and you're running the fertilizer with, now you could be with a human running the tractor or quotes, the satellite, unquotes, running the tractor, and you're changing the fertilization rates as you go. So that level of data, so you've got to have the data. Another one that's come out, and it's a big, big thing, is laser weeders.
Yeah.
Now, they'd already developed, more specific chemical weeders where instead of broadcasting the chemical, you're running this thing over there, seeing the plant, zapping it. We had in our symposium in September 24, the carbon robotics, running a cart down the field, camera scanning plants, identifying the plants, and hitting them with a laser. Okay. Now, that impressed the hell out of me. And in a year, there's like 6 of them on the market. But the folks, and this is the talk we're going to start in an hour with the Academy, is there's people following because people don't trust tech. They buy the tech, and you're running this laser weeder down the field, and there's people following it because it only identifies plants in a certain age range at this point in time. So you have people following it, pulling up weeds. But if that laser bounces off a stone, it can hit the worker walking behind the weeder. Or a farmer loves technology, but he doesn't trust it. And he literally spends tens of thousands of dollars on this laser weeder and is told, use it at these times. He's bought it, so he wants to see it being used. And he's running it down a field where the weeds aren't even up yet or where they're too far gone. So all of those issues, which you may think didn't answer your question about data, but all of those things are based on databases. Okay?
Oh, yeah.
So all of that. I mean, and that's my struggle is how do we get folks who live and work day to day as agriculturalists, farmers, farm companies, those kinds of things. How do we get them to throw some, as we've said before, budget dust our way as scientists? Okay. Literally. All right. Other questions? I can't see everybody. So let's see if your hand comes up. Well, Marcella, I think we've fulfilled our destiny for today. So and thank you so much for that involvement here at the end. With that, I think I'll give you back 4 minutes. See you in Kansas City or virtually.
Yes, don't forget to register before Friday if you're going in person. The link, I put it away already.
Oops. Okay. Thank you, everybody.
Thank you, John.
Yep.